Hi, welcome to MPC Classes. Good evening. Ninth class, chapter 1, Matter around us. What is matter? Anything in this world which has mass and occupies the space is known as matter. Chair, wood, chalk piece, pencil, eraser, stone, sand, dust, everything considered as matter. So you know very well about Panchatattva: air, earth, fire, sky, and water. So in that same manner, according to them, all the living and non-living things constituted of Panchatattva. Now, modern days, scientists have evolved two types of classification: physical properties on the basis of physical properties and chemical properties. Physical nature of matter. Particles of matter are very small. The smallest particle known as atoms. Between the particles of matter, space is there, and these particles are moving continuously, and these particles are attracting each other. These are the physical nature of the matter. Kinetic energy. So you know very well, we can explain on the basis of Brownian movement. If you take pollen grains in water, glass or bucket, if you see the momentum of pollen grains, we can say particles of water molecules are moving continuously. This was explained by the scientist Robert Brown. This is known as Brownian movement. So we can say all the particles of solid, gas, liquids are moving. They have kinetic energy. Dif- diffusion. Diffusion is nothing but the spontaneous intermixing of particles of two different type of matter on their own is called diffusion. If you burn incense stick, we'll get the smell by sitting in the any corner. If you sit in the garden, by sitting several meters away from the flowers, we'll get the smell. These are the examples of diffusion. Here three beakers are there. In first beaker you add potassium permanganate, which is in purple color, or you can add copper sulfide, which is in blue color, or you may take black ink, blue ink, red ink, whatever it may be. So when you drop 2-3 drops of ink, we can see the color diffuses fastly throughout the beaker, uniformly distributed. This is known as diffusion. Intermolecular forces. Solids have very much closer attractive forces. We can see first diagram, which are there gray color balls. All the particles are very close to each other. Intermolecular space is very less. You remember here, intermolecular attraction forces are inversely proportional to the intermolecular space. If the intermolecular attraction force is much, space will be less. If the intermolecular attraction forces are lesser, intermolecular space will be more. You can see liquid, their intermolecular space is more compared to the solid, less compared to the gas, and intermolecular attraction less compared to the solid, more compared to the gas. And if you see the gas here, we can see directly intermolecular space is very much, but attraction is lesser. States of matter, we know very well, we have three states of matter: solid, liquid, gas. So first one is solid, yellow color balls; liquid, green color balls; gas, pink color balls. So solid state, let us see the properties. The molecules are very tightly packed, and molecular forces of attraction is very high in solids. Solids have definite shape, distinct boundaries, and fixed value. They have tendency to maintain their shape and size unless and until an external force acts on them. That is why they are rigid and hard. Moment of particle is negligible and possess least kinetic energy. Solid possess high density. The rate of diffusion in solid is very less. Solids are negligible compressible. Negligible compressible, that you have to remember. Liquid. Liquid state. The properties of liquid. The molecules are loosely arranged, and the intermolecular forces of attraction is less in liquids than solids. Liquids do not have fixed shape, but it can gain the shape of the container. whatever it may be the shape, that shape it may get. They have tendency to flow and are also called as fluids. Here you have to remember fluids are nothing but liquids and gases both. Fluids nothing but which can flow easily. So liquids, solids both are example of fluids. Momentum of particle is high and possess high kinetic energy. Liquids have low density. The rate of diffusion is higher in liquids than solids, but compared to the gas is less. Liquids are highly compressible, but compared to the gas it is less. Compared to the solid, highly compressible. Gaseous state. The molecules are very loosely packed and intermolecular forces are attraction. Forces of attraction is least in gases. Gases do not have fixed shape, do not have fixed volume, and highly compressible, low density, diffusion also more, intermolecular space is more, internal attraction is very less. These are the properties of solid, liquid and gases. So here table is there, you have to remember this table. It is easy to remember. Here properties are there: shape, rigidity, compressibility, fluids, filling a gas in container, kinetic energy, density. Already I have explained all these things. You go through this, pause the videos, take the screenshot and go through this. Can matter change its states? Conversion of solid to liquid, liquid to the gas. Solid to liquid is known as melting, liquid to gas is known as evaporation or vaporization, and gas to the liquid condensation, liquid to the solid freezing. If solid is directly converted to the gas, sublimation. If the gas is converted to the solid, reverse sublimation, or we can say hoarfrost. Okay, these are the terminology you have to remember. Here we have an experiment: solid, liquid. Here beaker is there. In that beaker you take ice, heat it with Bunsen burner, keep temperature thermometer. When you heat that, what will happen? At 0 degrees Celsius, exactly 273.16 Kelvin temperature, it is a melting point, or we can say fusion point. So here a solid start converting into the liquid. So we can say melting is nothing but fusion, remember. Okay, next, liquid to the gas. Same experiment you do, you take water and heat it with Bunsen burner, take the temperature, check the temperature with thermometer. If the temperature of thermometer increasing up to 100 degrees Celsius, water starts boiling and it starts evaporate. This process is known as evaporation or vaporization, or we can say boiling. So here boiling point 100 degrees Celsius, that you have to remember. Next, gas to the liquid. Condensation, you know very well. In winter season we can see the droplets upon the grass because of condensation. Because of condensation we are getting rain, water cycle. And because of condensation in winter season, from our mouth whatever the moisture is coming, it's look like a smoke or small cloud. Okay, so this is condensation. You can see that when we are cooking something else, if we keep a vessel lid upon the vessel, what will happen? Water evaporates. After evaporating, if it condenses, we can see the water droplets upon the vessel. Liquid to the solid, freezing. Okay, if we keep water in the fridge, will become freezing, or we can say solidification. Okay, all these things you have to remember. Solidification, freezing, same only. Solid to the gas, sublimation, I said to you. Okay, about the sublimation is matter around us pure, in that I have explained very nicely by taking the activity. Here I will explain directly. We have to take a funnel, invert it, close the mouth of the funnel with cotton, take naphthalene or camphor or ammonium chloride ball or iodine or dry ice. So you heat it, we can see that solid directly converted to the gas. Okay, by the walls of the funnel we can see that gas again converted to the solid. Sublimation, reverse sublimation. Okay, or we can say deposition, reverse sublimation. I have read in one book, IIT. So this also can called as hoarfrost. HOARFROST, hoarfrost. We can see reverse sublimation, that is enough, no problem. Interconversion, already I said to you, solid to liquid is melting, liquid to gas is vaporization, gas to liquid condensation, liquid to solid freezing, gas to solid sublimation, solid to gas sublimation, gas to solid reverse sublimation or hoarfrost or deposition. Conversion of dry ice, you know very well, dry ice, directly solid state to gas it will be converted. Dry ice is stored under the high pressure, solid carbon dioxide gets converted directly to the gas. Decrease of pressure to 1 atmosphere without coming into the liquid state. This This is the reason that solid carbon dioxide, also known as dry ice. Latent heat of fusion. What is meant by latent heat? Clearly that here graph is increasing directly. It means solid is converting into the liquid. This process is known as melting. So to melt that ice, we need some energy. That energy is known as latent heat of fusion. Temperature must be same. Okay, here flat line you can see the same. Assume that you have ice. When you heat that ice, directly total ice converted to the water. It won't convert. Then what we have to do? Check clearly. When ice is there upon the vessel, then first what will happen? All ice will be converted to the liquid slowly, slowly, slowly. To convert the total ice to the liquid, that temperature will be same until the all the ice cubes converted to the water. So it needs some energy. This energy is known as latent heat of fusion. Latent heat of evaporation, same thing. You take the vessel and see the water. If the water is started to evaporate, then you can see clearly that when water is evaporating, it will take some time. All the particles, all the molecules of water, until it achieve 100 degrees Celsius, it won't convert it to the vapors. Okay, so when all the water molecules are reaching 100 degrees Celsius, it start evaporating. So temperature is same until get 100 degrees Celsius, but it is taking some energy. We are heating that. That energy is known as latent heat of vaporization. You know evaporation. Evaporation is nothing but directly liquid converted to the water. Because of evaporation, we are getting rain. Water cycle, you know very well. It is there in 7th class. So factors affecting evaporation: surface area. Bigger the surface area, we can get dry cloths very fastly. When you are drying the cloths, temperature. In summer season, we can get dry cloths fastly. In winter season, it will take time. Humidity. As the humidity increases, evaporation will be fast. As the wind speed increases, evaporation will be faster. Okay. Increasing surface area. You can see here cloths are drying by increasing the surface area. Increasing temperature. In summer season, we can see the evaporation will be faster. Humidity. As humidity is more, easy evaporation. Increase the humidity. Wind speed. As the wind speed is more, okay, in a winter season, if clothes are not drying, we are keeping in front of the fan. It will get dry fastly. We will get little bit smell. That is a different thing. How evaporation causes cooling? So we know very well evaporation causes cooling. In an open vessel, the liquid keeps on evaporating. The particles of liquid absorbs energy from the surrounding to regain the energy lost during the evaporation. This absorption of energy from the surroundings make the surrounding cold. Okay, so in our language we can say clearly that when evaporation is taking place, higher energy containing molecules evaporate fastly and lower energy containing molecules will be there in the vessel only. When you take the total mean of the energy which is present in the vessel which is having lower energy, because of that lower energy we will feel cooler, vessel will become cooler. Example, when acetone gets poured on palm, the particles gain energy from our palm or surroundings and evaporation causing palm to feel cool. Okay. When some people pour water on the rooftop on a hot sunny day, people sprinkle water on the roof or open ground because the large latent heat of vaporization of water helps to cool the hot surface. Okay. So you remember higher energy containing water vapors are evaporating fastly. Lower energy containing water vapors are present in the vessel. If you take the mean of the total lower energy containing water particles, then that energy will be less. Because of that cooling takes place. We can say evaporation cause cooling. So why to wear cotton cloths during the summer? You know very well. Okay. So during the summer we I mean because of the mechanism of our body which keeps us cool, that is nothing but evaporation. The particles at the surface of the liquid gain energy from the surroundings or body surface and changes into the vapor. The heat energy is absorbed from body, leaving the body cool. Okay, because of that we have to wear cotton. Okay, one reason is that because it causing coolness. Second reason is that this white cloths don't absorb UV rays, sunlight. Because of that we won't get our body won't get that much heat energy. If you wear black shirt, your body may become heat. Okay, so it is the fourth state of matter, very very important, which is known as plasma. The state that is comprises of super energetic and excited particle is called plasma. It is a fourth state of matter. Example, fluorescent tubes, neon bulbs. Inside the fluorescent tube or neon bulb, the gas gets ionized. We can say plasma is nothing but intermediate stage between the gas and ions. We can say ionized gas it is. Gas gets charged when electrical charge flows through it. This creates the plasma glow inside. The sun and stars glow because of the presence of plasma in them. The plasma inside the stars get created because of high temperature. We can say plasma is nothing but super hot situation. Okay. Right. Now here you can see the picture, that is a plasma. Bose-Einstein condensate. You can see the picture here. By the 1920 Indian physicist Satyendranath Bose and Albert Einstein, they both together they gave this concept. So that time they did not show this practically. Then other scientists, Cornell, Wolfgang Kettel and Wieman. So these are the scientists, they have showed this Bose-Einstein condensate practically. BEC, Beck, nothing but Bose-Einstein condensate. BEC is formed by cooling a gas of extremely low density to a super low temperature, that is below absolute temperature minus 273 kelvins. Okay, so you remember plasma is a super hot situation. Bose-Einstein condensate opposite to the plasma super cool state. Okay, super hot state, super cool state. Plasma super hot and Bose-Einstein super cool, that you have to remember. With this we have completed our first chapter, matter around us. Thank you.